cathode rays. I'm not going to be drawing all the experiments involved, but just explain them in imaginative detail. Okay. He found out that ordinary pressure gases are electrical insulators, but when subjected to low pressure and high voltage, they break down and conduct electricity, and the glass container begins to glow. The experiment showed that this was caused by bombardment of the glass by rays originating from the cathode and travel towards the anode. The cathode is the negative electrode, anode is the positive electrode. Okay, so at low pressure, gases are insulators. Okay, according to experimental results. But when you increase at ordinary pressure, gases are electrical insulators. When you lower the pressure and increase the voltage, increase the current that passes through, you find out that they conduct electricity. The container of the glass, like the cathode ray tube, begins to glow because the particles that move through them, they are somehow they are negatively charged. Okay, they travel towards the anode. Like I said, positive and negative, they come together. All right. So I'm not going to draw the diagram. Let me just give a simple sketch. I don't want to make it complicated. Let's see. We have okay. Let's see. We have this one here. We have this one. We have this one. Okay, this okay, so this is the cathode rays. Okay, this is a simplified discharge tube. Alright. This is the anode. This is the cathode, this is the anode. So they move this way. The direction of their movements is this way. So Thomson discovered subatomic particles called electron, which are small and negatively charged. Alright. Use the cathode ray tube to discover the electrons. Okay, this should be discussed in higher studies. I think this is just the brief description of what happened as Thomson carried out the experiment. This is just, let me say, a summary of what happened. Okay, he reduced the pressure, increased the voltage to like 10,000 volts. Okay, a noisy spark was heard and just it jumped a few fraction of the inch through air into the tube. Okay, but when the pressure is reduced, okay, and that same voltage is applied, discover that the pressure in the tube was about 1 torr. Applying the same voltage, the current produced now travels from the cathode to the other end of the tube, and the residual gas produces a glow. Alright, at ordinary pressure and increased voltage, just notice a spark and nothing actually happens. Like there's no movement, just a spark. It just jumped through a tiny fraction of air. But when the pressure is reduced, there's movement. Something travels through the cathode ray tube, and the residual gas begins to glow. That shows there are particles that are moving through the gases. Okay, so just a brief description of what happened during Thomson's experiment. Okay. He also measured the charge to mass ratio. You measure the charge to mass ratio of the charge to mass ratio. Yes, charge to mass ratio of the particles making up the cathode rays. Alright, that happened long after doubting, maybe like 90 years after. Okay, which was called electrons by Stoney. No need to bother with those details. Just note that Thomson measured the charge to mass ratio. Okay, each discovered to be about 9.1 times 10 to the power minus 31 kilograms, or in kg 10 to the power minus 28 grams. Alright, you know the charge to mass ratio, which is limited as this, or okay, 9.1 pardon my 1.6 times 10 to the power minus 19 kilocoulombs of the that's the mass. The mass was measured to be about 9.1 times 10 to the power minus 31. Okay, the charge to mass ratio was measured to be 1.76 times 10 to the power minus 11 coulombs per kilograms. 1.76 pardon the error, just kind of a mix up there. This is the charge to mass ratio. Alright, after having found the charge to mass ratio, in his experiment, the cathode ray experiment, it was named electrons by Stoney named them electrons. Alright, he named them electrons. Okay, just as it progressed, Thomson, we also talked about we measured 3 particles that compose the atom: the protons, the neutrons, and the electrons. Let's not talk about the protons. Alright, the protons are positively charged particles. Okay, let me give you the mass of the electron. Okay, mass minus 31 kilograms. Okay, this is the mass of the electron. So from this you can calculate the charge of the electron. So charge is something like a 1.602 times 10 to the power minus 19 coulombs. Okay, 1.602 times exponential minus 19 coulombs. Alright, so these are the values, charge to mass ratio. This Thomson's experiments give us these values from the cathode ray experiment. Okay, you also found out that the mass of the electron was 1/1836 times that of the hydrogen atom. So you can also deduce how small the electron, or how tiny, how light the electron will be. 1/1836 times the hydrogen atom, that of the hydrogen atom. So the reason for that little value, or very small value of that mass, so minus 31 kilograms, exponent minus 31 kilograms, that's so small. I'm sure you can't even see the electron with your naked eye. That's just this. He suggested that electrons were present in the atom of all substances, and the electrons of an atom accounts for that negligible fraction of its mass. When you calculate the mass of the atom, it's a negligible part that we found out in the experiments, and the electron was responsible for that mass, that negligible, because of the small value of the mass Thomson's got. Okay. During the experiment, Thomson also noticed the red glow around the cathode in the experiment, and the red glow appeared from the opposite side of the anode. Okay, he just used the perforated metal disc as a cathode in the discharge tube. As experiment, Cham moved on and found the proton. This red glow was caused by rays which were developed by magnetic and electric fields in the opposite direction of the electrons. This shows that they contained positively charged particles. He called these rays positive rays. Alright, so these positive rays, they required much larger fields than electrons because of their deflection. This means from this finding we can say that the protons are much more heavier, and they are not as fast as the electrons, because they require much or larger electrical field or magnetic to be deflected. All right, so the mass of the particles depends on the nature of the gas inside the discharge tube, and so we found out in the electrons, the mass of the electrons was independent of the gas in the discharge tube. But when you find out that when we change the mass, the gas, it affected the deflection. All right, so it's just this parts of the atomic theory needs to be carefully considered. Okay, this means that all particles of the cathode ray are the same, and they have the same charge to mass ratio and move at the same speed. Okay, at the cathode rays, they have the same charge to mass ratio, and just okay, and move on, and the mass of this electron was discovered by Millikan. He described the experiment. This mass was discovered by Millikan. Okay, in the oil drop experiment, we won't go to the description of that, but the mass of the electron was discovered by by Millikan in the oil drop experiment. Just this experimental discovery also proved that this mass, these electrons are negatively charged, just to prove the fact. Okay, okay. During this experiment, the discovery of the electrons, physicists also predicted or they proposed that there will be positively charged particles traveling in the opposite direction of the cathode rays towards the cathode, and this Goldstein proved the fact. He used the perforated cathode and carried out these experiments, and they responded to magnetic field but in the opposite direction as would the cathode rays, hence they must be positively charged. Okay, during the same methods for the electron, they performed the same experiment on the positively charged particles or the protons. We discovered that these particles are pardon me. These particles are much more heavier than the electrons. Okay, positively charged. And J.J. Thomson with Aston Martin, also made an experiment or performed an experiment to find out that this Thomson model of the atom is not just a a simple sphere object as Daltons are proposed was made up of at least two parts, one of which is the electron. This atom is not just um, a spherical object, but according to the experiment, they are made up of they're made up of two parts, one of which is the electron. And there's some facts that also proved it. When the fast moving electrons of the cathode ray bombarded the gas molecules, it caused them to lose an electron from the atom. Okay, so it means they had the ability to knock off um, um, electrons from an atom. Okay, when these fast moving electrons from the cathode is bombarded the gas molecules, they cause the gas molecule to lose an electron from the atom. So these atoms must therefore be must be neutral for you to knock off an electron, and that substance becomes positively charged. That means that substance must have been neutral, electrically neutral, and so produced positively charged particles which are attracted to the cathode. Okay, also this also put many things into consideration. So Thomson concluded the positive rays were produced when electrons in the cathode rays collided with gas molecules in the tube. Okay, these electrons split the molecules into atoms and strip off one or more electrons in the atoms. Then these atoms are converted to positive ions by removal of electrons. Okay, during this experiment of the cathode rays, as the fast moving electrons traveled towards the anode, they collided with gas particles, knocked off electrons, okay, is plus. Okay, so this is a schematic. So these electrons were the ones stripped from hydrogen atoms. So this is the hydrogen ions. Okay, so this discovery by Thomson, okay, now it's made up with this fact that there are also positive rays which are called protons. Okay, and this the highest positively charged rays was that of the hydrogen ion. Okay, the hydrogen atom that has lost an electron. So this brought about the electrons and the protons of an atom, totally bringing to null and void the Dalton's atomic theory. A part of it that said atoms are the tiniest particle of a substance involved in a chemical reaction, or he said atoms can neither be created or destroyed. Okay, that means in a chemical reaction we have only separation, combination, and rearrangement. This discovery, or these discoveries, disproved those theories of Dalton's. Okay, so moving further, we will talk about Rutherford's alpha scattering experiments. Okay, this alpha scattering experiment was followed by was demonstrated by Rutherford following Thomson's work. Okay, Rutherford proposed the existence of a positively charged nucleus. Okay, the bombardment